Some motivation for diagonal matrices. We've talked about them before, but I just want to say one more piece about them very quickly just before we get into diagonalization, which is the magic here. So here's an example. It's a n by n that we're talking about n by n. So this is a 3 by 3 diagonal matrix. If we raise that to a power, it's incredibly simple, right? Just if you don't believe me, you can multiply a few out. We just do a very naive thing that you might think you would do if you've never heard of matrices before and someone said raise this thing to a power. You might just raise all the entries to a power, and that is exactly what happens for diagonal matrices. So what A does to X in this case is very simple, right? So A times X is just going to be 3 times the first entry minus 7 times the second entry and 17 times that last entry. Very simple. And the way, and if we find the eigenvalues and eigenvectors, they just pop straight out, right? So the eigenvalues are always just going to be what the entries are on the main diagonal. And the eigenvectors are always going to be the so-called natural basis. So this is the natural basis, natural or standard basis for R3, right? So that's very, very simple. So if we're working with just diagonal matrices, everything will be super easy. So here's our example that we've been working with. Right, we're quite happy with this little beast. Does some nice things. So it has eigenvalue, it has a 3 halves and a half, right? So there's a expansion in this direction and contraction in this direction. If we multiply a matrix, a vector by this matrix. And we could think of this, right? So here's a nice way to think about it. This, all the vectors here, A times all of those vectors will end up here, right? So A maps that circle to this ellipse. We've talked about other ways of thinking about this, but A maps circle to an ellipse. And that ellipse is oriented at this 45-degree angle, right? So this is A's preferred way of thinking about the world, if you like. So if we could rotate the axes, then what A does will be very simple. And so the big idea is going to be this. These are two huge ideas, right? So if we could rotate the axes, A's action would be simple. And the big idea is that we do that, right? So we change from the standard basis to the eigenvector basis. So we're kind of just going to do that to start with. Then we're going to talk a little bit about changing bases in general, but that's a pretty cool thing to see, right? So if we could just rearrange things and just represent vectors, right? So instead of thinking this vector is this piece, we want to think of it as made out of some multiple of one eigenvector plus a multiple of the other one. And in general, some linear combination of eigenvectors. All right, so this is the setup for diagonalization. Let us do it.